Is the Earth truly at the center of the universe, or is the Sun? For centuries, the geocentrism versus heliocentrism debate sparked fierce scientific and philosophical battles. But what if both views are missing the bigger picture? In this video, we dive into how Einstein's theory of relativity revolutionized our understanding of motion, reference frames, and the very fabric of space-time, and in doing so, changed the way we think about our place in the cosmos. The number one assumption that both sides in the heliocentrism versus geocentrism debate have had has been the presupposition of absolute motion. They may not specifically state this assumption, but inherent in both perspectives is the idea that one is at absolute rest and everything else is moving around it. From the perspective of life here on Earth, this seems like a reasonable assumption because all of our motion is relative to the surface of the Earth. However, this introduces a natural bias towards seeing the Earth as being at absolute rest. When you switch to a heliocentric model, it is easy to see the Sun as being at absolute rest, and the Earth and other planets moving in absolute motion around it. However, the ultimate solution is to abandon this idea of absolute motion altogether and see all motion as being relative to other motion. This brings an end to the conflict by bringing an end to the core assumption of absolute motion. Special relativity deals with the effects of the relative motion of objects when not accelerating. One of the key concepts of special relativity is that there is no such thing as absolute motion. This means that all motion is relative. In fact, the only motion that can be legitimately considered absolute is the speed of light because that speed is constant for all observers, regardless of their motion relative to other observers. One of the consequences of this is that as you approach the speed of light relative to the surrounding matter, time for you tends to slow down relative to that matter, and length tends to contract, meaning that your travel time and distance both become shorter. And in fact, it can become incredibly short if you get close enough to the speed of light. However, special relativity shows that the assumption of absolute motion, which is core to the heliocentric versus geocentric debate, is completely wrong. General relativity deals with acceleration. In fact, under general relativity, gravity is space itself accelerating towards an object, dragging other objects with it. When this acceleration meets a surface, the result is the same as what you get if you are accelerating under a force such as that of a rocket during a launch. Space can also move in a circular motion, an effect which is common around black holes known as frame dragging. Furthermore, under general relativity, it is possible for space itself to rotate around an object, producing all of the effects that would result from the object itself rotating. As a result, under general relativity, even rotational motion can be considered relative. This completely eliminates any possibility of absolute motion, be it linear or rotational, that is required for geocentrism or heliocentrism to be absolutely true. Understanding the relative nature of linear motion is the first clue to understanding the solution to this problem. This is in part because orbital motion is usually wide enough to, for all practical purposes, be identical to linear motion. This can be illustrated by the fact that, even from a heliocentric perspective, during the course of an hour, the Earth's orbital motion around the Sun is very close to that of a straight line. Furthermore, the uniform nature of gravity adds to this effect. We can actually observe this effect while driving down the highway. Not only are we motionless relative to our own car, but other cars driving down the same road show different relative motions to both us and the ground. This is particularly true of cars going in the opposite direction. In fact, the only reason we have a standard for speed on a highway is because we arbitrarily set the Earth's surface as the 0 point. Now, while moving along the Earth's surface, using it as a standard 0 point of motion is a good idea, but it is still an arbitrary figure, just one that happens to be particularly useful. Despite the inertial effects associated with rotational motion, it too is relative to other frames of reference. A good example of this is the fact that astronauts in a spacecraft orbiting the Earth, such as the International Space Station, are weightless, despite the fact that they are in rotational motion around the Earth. While part of this is a result of the uniform nature of gravity, it is also a result of the fact that the spacecraft is following the curvature of space-time around the Earth. In fact, even if you are inside a centrifuge, you do not actually notice the fact that you are moving in circular motion. All you really do is feel an increased gravitational effect caused by the centrifugal force. Furthermore, under general relativity, you could have space itself going around the object, producing all of the inertial effects that are observed under regular rotational motion. Frame dragging near a black hole is an example of this type of spatial effect causing a change in the relative rotation rate of an object. Once you eliminate the concept of absolute motion, then geocentrism versus heliocentrism becomes nothing more than a matter of perspective about the motion in the solar system. Geocentrism is the perspective on the motion of objects in the solar system as seen from the Earth. Meanwhile, heliocentrism is the perspective of the motion of objects in the solar system as seen from the Sun. It is actually that simple. Now, calculations from a heliocentric perspective are easier, but trying to claim that one or the other is absolutely correct is not consistent with special and general relativity. Ultimately, geocentrism versus heliocentrism is just a difference in frame of reference. You can choose any other frame of reference in the solar system that you want, and it still works. You can choose one that is Martian-centric, Venusian-centric, Mercury-centric, Jupiter-centric, Saturn-centric, Uranus-centric, Neptune-centric, Pluto-centric, Ceres-centric, and a whole bunch of other bodies around the solar system, from which you can look at the motion in the solar system. Not only that, but you could put a spacecraft in orbit around the Sun or any of the planets and look at the motion of the solar system from its perspective. It is all just a question of choosing a frame of reference and looking at the motion in the solar system from that frame of reference. It is that simple. In conclusion, by eliminating the presupposition of absolute motion, special and general relativity eliminate the controversy between geocentrism and heliocentrism, because both of them are reduced to nothing but specific frames of reference. Furthermore, there are multiple other frames of reference that could be used to describe the motion of bodies within our solar system. The final point is that the entire issue is moot, because they are arbitrarily chosen frames of reference and nothing more.